Good evening, good evening, good evening, my dear JEE warriors. Yes, a warm welcome to all of you. Last time when we all met with Vikas sir, it was super duper amazing with some amazing tricks and we saw the comments. That's why we are coming here again. And this time with some skibidi Olympiad concepts, meaning very cool Olympiad concepts. So all the Gen Z people would definitely know what this means. And let's slay it, my dear JEE warriors, because these concepts, whatever you're going to learn, you can use it not just for JEE Advanced but also JEE Mains and other examinations, and it will help you solve the questions within seconds, not even minutes, and will make you practice these concepts. That's it. I mean, other people will be taking a lot of time, but you will be doing it within few seconds, right? So let's do it. I hope you guys are all ready for all the tricks, and quickly like the video. Welcome everyone. Okay, so let's call upon Vikas sir. Yes, our Eklavya master teacher, Vikas sir. Welcome sir.
Hi students, thank you sir, thank you for having me again.
Yes sir, last time it was full on, I would say, I mean it was on fire, that session, the NSCP session that we took, and this time again for Olympiad level concepts which we can use in JEE. So you have planned something killer sir this time?
Yes sir, so I've seen that students generally struggle a lot in phase related questions or equation related question in SHM.
Right.
So today I'll probably demonstrate a particular situation and how phase method can be used in that, and how easy it becomes to analyze the situation if we are using the phase method properly. Like, knowing the method is one thing,
yeah,
but to be able to recall and apply it when needed, that is altogether another thing. So we'll see how we can do that.
Yeah, because I've seen, sir, usually students, whenever they study SHM and waves, they just go into the mathematical part of it, even while solving. They just study that the projection of UCM is SHM. Only for that perspective, they study the phasor diagram. And later on, directly in 12th standard in AC, they see the phasor diagram. That's it.
Yeah.
Usually.
And the point is that is a very powerful tool. Many questions in SHM, especially the equation related, I've seen that the students struggle with the equation related question. But when you start using the phasor method properly, then those questions become very easy, which otherwise look very, very difficult.
Okay, so let's begin, sir.
Sure.
So
sure.
I hope you guys have smashed the like button if you have not done that. Come on, guys. And put some fire emoji in the chat box right away, right now, okay? Yeah, and we'll answer all your doubts later on, or maybe you can put it up in the comments, okay? Because these methods are very intensive, so full focus over here. On to you, sir. Okay, what is the question?
Okay, sir, I'll first present the situation, okay, that what is the situation that we are discussing. Okay, so, yeah. Fine. So basically, let us say that this is a horizontal plane. Okay, this is a horizontal plane, and let's say this is a vertical wall. Okay, and we plan to attach two spring block systems to this on this plane. Friction is absent everywhere. There is no air friction, like there is no effect of air also. There is no ground friction also, nothing. Okay, now what we are doing is that we are using two identical spring block arrangements. So one is, let's say, here. Okay, so this is, let's say, one of the block. Okay, attached with the spring constant is K and mass is M. And then right next to it we have another spring block arrangement, identical length, identical spring, identical mass, everything same. Okay, so two identical systems side by side. Okay, and let's say that the natural length of the spring, so that is this position, let's call it as X. This is 0. Yeah. Okay, now the thing is that we plan to pull both these blocks by the same distance. Okay, and then we will release one. We'll wait for some time. Then we'll release the other one. Okay. So they will oscillate somewhat like this. Okay. And now in these oscillation, they will cross each other multiple times. And so if they're crossing each other, then it means that they are acquiring a zero distance.
Yes.
Like if we talk about the horizontal, like the distance along the X, that will become zero. That will again become non-zero, and it will become zero, which means that somewhere in between it should have acquired a maximum also.
Maximum separation.
Okay, so we will talk about that. What is the position where they are acquiring maximum distance from each other when they are doing it, and if we call this event as event X, let's say, like they are acquiring maximum distance from each other. Let's call it as event X.
Okay, let's write it down. Maybe A or B, or also we can write it down.
Yeah.
Okay. So event A and event B. Okay.
So A is when blocks cross each other.
Okay, blocks are crossing each other.
Okay. So that's event A, and event B is blocks are at maximum separation from each other.
So I hope you understood this concept that once you pull both these blocks and if you had released it simultaneously, both of them would go like this. But if you release one and then you release the next, then it will go like this. It will go something like this. And just look at the movement of my hands. You can see sometimes they are crossing and sometimes the separation between the blocks is maximum. So that is what is going to happen.
Yeah.
Yeah. And it is randomly you have left. It is not like
Yeah.
after
So
some specific
for explanation purpose, for students understanding purpose, we'll tell that after really leaving one, when we are leaving the other one, from this we'll we'll take one particular situation as an example, and from there the student can learn that what if the time is different than
arbitrary.
what to do. Yeah.
Okay.
Yeah.
Okay. Fine. Okay.
Okay. So how we are going to attack this question? So let us say that we are pulling it by a distance L maybe. Okay, and we are also pulling it by a distance L, and let's say we are releasing, let's call it as A and B we have already used, so let's call it as X and Y blocks. Okay, so we are first releasing X. Okay, and when X has reached the mean position, when X has reached its own mean position, okay, it is then that we are releasing Y. Okay, so we can consider that as t equal to 0 moment. Okay, so when X would be moving through this position in this direction, Y would still be here, and we have just released Y, and we are treating this as t equal to 0. Now the question is that at what time the blocks are going to cross each other, at what time they are going to be at maximum separation from each other, what is the location where the blocks are going to cross each other, and so on and so forth. Okay, so this is what we are going to solve. Okay, so
normally how would you solve? Just put it up in the comments. What would you do, guys? Yeah, you will write the equations. X is equal to a sine omega t.
Whatever comes to your mind. Yeah,
like that, the mathematical way, the trigonometric way, and then you will find the solution of the trigonometry, and then you will find those times when it is equal. It is a headache, I would feel.
So students, keep in mind that we are analyzing the entire situation. We'll break open the entire situation so that any question which is asked on this situation, you are able to address that. So again, that is what we teach in Eklavya, that instead of attacking a question, you attack the situation described in the question. Think about that situation from all perspective, so that whatever question can be framed on that situation, you are well versed to do those questions.
Correct.
So let's start, sir.
Okay.
So
next slide or something.
Yeah. So sir, my question to you, like, this block, we'll come back to X. So at t equal to 0, X was moving through its mean position,
right,
and it is moving in a certain direction.
Right.
Okay, we can choose one of the direction as positive. So let's decide that this is positive direction. This was X equals to 0. Let's say this is positive direction. So at t equal to 0, this block was moving towards
negative direction.
Negative direction. Okay. Now, if I want to represent its motion on a circle, my first question to everyone is that what would be the radius of the circle that we are going to choose, or in other words, what is going to be the amplitude of this oscillatory motion?
Yeah, okay. It will be basically L only.
It will be L because we have released it from here, so this will become one of the extreme position. This is the mean position, so the distance between them is L, so the amplitude is L.
Extreme to mean is the amplitude, because it will go to the other side, so it will go like this. So this or this is the amplitude. Perfect.
All right. So if we have to represent the motion of A, X. Okay, so we'll draw a circle.
Okay. We have a beautiful circle, sir.
Okay.
I think we'll get it over here.
Yeah, I think that will help.
Yeah. Oh.
Okay.
Fine.
And can we get rid of this?
Yes, sir.
Okay. So now, sir, on which axis do you take the projection? Like on X axis?
You can take an X or Y, but I think X will be easy.
Fine.
Because for them to visualize
the
motion.
So let's say this is the ground, and the projection of the particle. Okay. And the center of the circle will become the mean position. Okay. So this is, let's say, X equals to 0. Okay. And so at t equal to 0, the first block, the X block, that is moving towards negative x-axis, and that is crossing through origin. So in this circle, where are we going to consider the position?
Are we going to rotate it clockwise or anti-clockwise?
Whatever you have taught the students. Let's go with anti-clockwise. Okay, let's
usually trigonometric side.
Yeah.
So then it will be here, so that the projection will fall here, and as it goes here, this point will go to the left side.
Right. So we will mark position. So this is the position of let's call it let me call it as A prime.
Okay.
X prime. Sorry,
I think it was
X. Yeah.
Okay.
So it would be X prime. So I'll write it as X prime.
Okay.
Okay, so prime indicates the position on the circle.
Circle.
Okay,
Okay.
X is the block and X prime would be the corresponding position on the circle.
Perfect.
Okay.
Okay.
And now this is going with an angular velocity omega. Okay.
Perfect.
And also the omega for their two system is same because
Same.
we have used identical spring, we have used identical blocks,
Right.
so omega is going to be same. Now at this very moment, where is Y prime?
Where is Y prime? So at that moment, it was at the extreme position.
Positive extreme.
So positive extreme. So the phasor will be here so that the projection will fall over here.
Yes. So this is Y prime, and again this is at t equal to 0, and this is moving with omega.
Correct.
Okay. Now this is something that everyone has to imagine now. So this phasor and this phasor, they are both moving at the same omega.
Correct.
So this angle will permanently remain as 90 degree. And
like this.
in the question, in this question, like one of the question in this situation is that what is the phase difference between the two?
Yeah.
Okay. So I think we have answered that question.
Yeah.
What is the phase difference between the two?
This is the phasor diagram.
So this angle is the phase difference. So
Correct, 90
in this present example, this is 90 degree. Okay. So again, one of the question that we asked in this situation is that, you have released one block, it is crossing through the mean position, you release the another block, they oscillate. Now, what is the phase difference between the two? The answer is 90 degree. Okay, or pi by 2. Okay, now they will keep on moving. Now we have to identify that, as they are moving, I want everyone to imagine a chord here. My question is, do you imagine the length of this chord to change or not? What do you think?
It should not change because this is fixed, the angle is fixed. So the triangle's dimensions are fixed.
Basically, this triangle can be considered to be made up of 3 rigid rods.
Correct.
Okay, this is the triangle. So I can consider this triangle as the rigid structure.
Correct.
And the entire rigid structure, I have a triangle made up of rigid rods.
L root 2.
And this is rotating with omega.
Right.
Now, what is the speciality of a rigid body? We have to understand that if any part of a rigid body rotates by a certain angle, any other part of the rigid body also rotates by the same angle. So, if this line rotates by 90 degree, we can be very sure that this would have rotated by 90 degree, this would have rotated by 90 degree.
Correct.
So, keep this in mind that when we are dealing with a rigid body, if it is convenient to think about one edge of the rigid body, you are easily able to identify that how much angle that edge has rotated, then you can easily claim that any other line has also rotated by the same angle.
Correct.
Okay, so that makes the situation easy for us. Now, at this very moment, the distance between the two blocks, the distance between the two blocks would be this.
To this, which is L.
Yeah, which at this very moment it would be L.
Correct.
And if we notice carefully, it is nothing but the projection of this chord on x-axis.
Nice.
Okay, so this chord is rotating, and at any moment, the projection of this chord on the x-axis is the distance between the two blocks. Okay.
Right.
Now, this is the most important realization that when we are talking about the distance between the two blocks, it is the projection of this chord, a chord the length of which is root 2L and which is not changing, and a chord which is rotating with angular velocity omega.
Correct.
Okay, so the projection of that chord is the distance between the two blocks.
Correct.
Now the question is almost over. For example, if I now ask all the students that when will be or how much will be the maximum length of the projection that we can get here. So can you think of that how the rod should be oriented, where it should lie so that the projection becomes maximum. So
okay, but yeah, think guys, this rod is like this, it's just going to rotate like that, and think when will the projection be maximum.
Projection on x-axis, when will it be maximum? So if you have concluded that it would be maximum when the rod becomes horizontal in this figure, then you are absolutely right. So we have answered multiple questions now. For example, if I ask you that after t equal to 0, when does the particle acquire maximum distance from each other for the first time?
For the first time.
The answer would be in the time in which this rod rotates by 45 degrees. And that would be pi by 4 divided by omega. I haven't written a single equation, and we have found out that this will be the time when the particle, when the event x was what? Can we check A or B? Which was maximum separation? B, event B. So event B occurs for the first time at this time.
Correct.
Okay, this TV1. The event B has occurred for the first time.
Those of you who got confused in this equation, guys, angle is angular speed into time. So time is angle by angular speed. Like time is distance by speed. So in circular motion, time is angular displacement by angular speed, right? So that is the concept. So angular displacement was 45 degree because this was like this. It became horizontal. So 45 degrees.
So this rod will become this rod will become like this. And again, guys, people get confused here. Most of the students get confused that when this rod went from this to this, how much angle did it rotate? We are not able to figure out. And therefore, I said use the concept of rigid body. When this rod went, this pink line goes from this vertical position to this position, and it has to be symmetric. So this angle is 45. So this yellow line has also rotated 45 degree. Okay. So this is, and now if we ask you that what is the maximum distance between the two? Okay.
What is the maximum distance between the two?
So that would be equal to the length of the cord.
Length of the cord.
Okay. So the maximum distance, okay, like delta x max, if I say, okay, then it would be simply root 2L. And now from here, if this part is understood, the next question could be, okay, when does event A occurs?
Yes.
Okay, when does event A occurs for the first time? So when does the projection of the cord on x-axis becomes 0? Because when it is 0, it is then that the particles are crossing each other. Okay, so when does it become 0?
So I think, sir, it will go like this. Like this also, it has not coincided. Here also, no. I think when it becomes vertical,
exactly,
from horizontal to vertical.
So when the cord becomes vertical, then the projection will be a point. Okay, and that is the distance is 0. So when this cord moves to this position, okay, when the cord moves to this position, okay, now this angle will be 45 degree and this angle will be 45 degree. Correct. So from horizontal to vertical, 90 degree of rotation.
Yes.
Okay, so this answer like TA1. So if I start from here to here, it took pi by 2.
Pi by 2.
So from here to here, it took pi by 4. So pi by 4 plus pi by 2 pi omega. That's the first time that event A will happen.
Correct. So 3 pi by 4 divided by omega, right? Everyone.
Okay. And now the students, I think you should be good enough to predict that what is going to happen next. Like if I ask you to comment on what is happening now, okay, then after exactly t by 4, see this is what this pi by 2 by omega is. It's basically pi by 4 omega, that is the previous value, plus t by 4 is what we have got.
Yes.
Okay, and now from this time to another t by 4, the rod will become horizontal. To another t by 4, the rod will become vertical. Another t by 4, again horizontal. Another t by 4.
Like a quadrilateral.
Okay, so after every t by 4 period, event A and event B will happen alternately. Okay, and if we want to do that, okay, one thing that we did not discuss, okay, what was the position of the block when they crossed each other for the first time? Okay, so then you can take the projection here. So this distance was how much? This distance was half of root 2L.
Half of root 2L.
So that is L by root 2.
Yeah.
So they were L by root 2 distant from the origin. One on this side, the other on the other side.
This projection, L root 2's cos whatever.
So L by root 2.
L by root 2.
Yeah. Okay. So you see, and now if some of you may be wondering that, are we getting this horizontal vertical thing because the phase difference was 90 degree?
Yeah.
In case if you are wondering that, okay.
Correct. What if we had left it when it has not reached mean somewhere here?
Yeah. So let's talk about that also. Suppose we left the other block when the block has traveled by a certain amount, let's say by that amount, which can give us an phase difference of 60 degrees.
60 degrees.
Let's talk about
any random angle, sir.
Yeah, okay, any random angle. So in that case,
we'll draw a new one. You are
yeah.
done? Okay, fine. Yeah. Yes, sir.
So if we can go draw the circle.
Oh, circle. Okay. Yes.
Okay. So if we are going with any random angle, okay, again, let's say we are taking the projection here. Okay. And any random angle, that means the first particle was somewhere here, and then we release the second particle. So this is the phase difference.
Correct.
And the chord is now this. Yes. This length is the chord now.
Correct.
Okay.
Correct.
Again, guys, the concept remains the same. When this chord becomes horizontal for the first time, okay, we get maximum separation between the particles. At some point, this chord will become vertical.
Correct.
And the projection will then become 0.
Yes.
So again, horizontal to vertical, it's still 90 degree of rotation.
Oh, nice.
So it's still t by 4 only.
So no matter what is the phase difference, every time the alternating event of coinciding or crossing each other versus maximum separation, it's always happening in an interval of t by 4. Then.
Yeah. And see, it is so simple. It is so simple. Like your first step is to locate both the particles at the same time on the circle.
Yeah.
Draw a chord. That chord, the length of that chord is the answer of maximum distance.
Correct.
Okay, and then you put this cord horizontally and vertically, so you get the positions where the crossing event happens or the maximum distance event happens. So you get that also very easily.
Wow, this is so cool, sir. This is mind blowing. I mean, so many questions. So phase difference done, crossing done, maximum separation done,
Position done.
position where it happens done, and how many times does it happen in one oscillation? Everything you can think.
And as an examiner, if I have to make this question complicated, I will probably ask, okay, tell me that when is the third time when the block are getting maximum distance. Now the students who rely on equation, they will get totally stumped if I don't ask for the first time.
Because you're going into the solutions of that trigonometric.
Yes, the trigonometric equation, multiple solutions the student will write, and then they have to pick the right one.
Yeah.
So the student is bound to mess up there.
Mistake.
Yeah.
Correct. Oh yeah, correct.
Okay, so
Amazing, sir. So, sir, any more applications of phasor diagrams, sir?
okay, sir. On phasor diagram, there is actually a brilliant question that I personally like very much. It's a simple question, but it's an amazing question. Students like that, and if the student understand that, then I give them a really, really tough question. One question which whoever can does in the first attempt correct, I can bet on that that student is going to IIT for sure.
Guys, are you ready for the challenge?
Okay, so
This is super duper interesting. Go ahead, smash that like button right away, right now, and fire it up. Get ready for the next question. Call all your friends right away.
Okay, so should I give a hint question that can lead to that solution, like, or should I directly give the?
Directly give, sir.
Okay,
Students are ready.
Okay, all right, sir. So I'm giving you one of my personal favorites in SHM. Okay, and if I have to ever bring down the morale of a student down, this is a question I use in SHM. Okay,
Confidence breaker question with it. Yes.
so this is a spring, this is a block. Okay, mass M, spring constant K. The system is at rest right now. Okay, and now what we are doing is that we are sending a bullet, let's say of same mass M, to keep the calculation simple. Same mass M, speed V naught.
Okay.
Okay, now this bullet goes and it hits the block.
Okay, so this bullet is going and hitting the block.
And it is getting embedded in the block. Okay,
So,
let's consider that as t equal to 0.
Okay.
Okay, now there are multiple things to ask here. That subsequently oscillation will start. We can ignore the effect of air. So subsequently oscillations will start. So finding the amplitude is one thing, and then the next, if I want to make it more complicated, is that after t equal to 0, when will be the maximum compression occur for the first time? So the spring will be under maximum compression at what time for the first time? So asking time is the real thing here. Like if I ask anything related to amplitude,
that is still okay. Energy equation.
Yes, the student rely on energy to do that. But the moment I ask starting about that, so and so event will happen at what time?
What time?
Okay, that time makes everything super complicated. So
okay. So guys, can you at least answer after the block is hit by the bullet, what will be the speed and which law are you going to use? Yeah, you're going to use conservation momentum. Yeah, and what will be the speed? Because M and M, double mass. So the speed will become half, right? So the speed will become V naught by 2 just after the collision, but the spring has not yet changed its elongation or compression at that instant. Okay, let's see what happens next, sir. Okay.
Okay, now I'll tell you, I'll tell that what the students does or what is expected. I'll tell you that where they commit. So students will proceed like this. Okay.
Yeah.
Bullet is embedded. It will require some speed.
Yeah.
We will calculate from momentum conservation that the speed is this much. Okay. Then this is the spring. Okay. Now remember, we are trying to find out the time.
Time. Time for what? We'll just write down the question just for clarity's sake. What is the question, sir?
So time after which spring is maximum compressed for the first time.
After which
spring is compressed, maximum compressed for the first time.
Spring is maximum compressed. Max compressed.
Yeah. Consider this as t, like this is t equal to 0.
First time.
When the particles hit.
Okay. Take it.
So after this we have to calculate. Okay. Now we got the speed. The next thing is to get the amplitude. We must get the amplitude now.
Okay.
So how do we do that? Like how do we get the amplitude now?
Yeah. So the spring has already some potential energy, some kinetic energy, and when it is maximum compressed, kinetic energy 0, maximum compression, some things.
So if we are relying on energy equation, we'll have to consider the gravity also.
Gravitational also. Yeah.
So we'll do that and we'll get the let's say we say that okay, the block comes here and now the speed has become 0. So this is the state of maximum compression in that case.
Yeah.
Okay. Now remember, we are looking to find out amplitude.
Yes.
Okay. So this displacement. Okay, like if I tell any further, I will reveal the trick here, like what the students miss. So the point here to realize is that this
becomes our new equilibrium.
is not the nuclear. Like this is not,
the new.
Yeah, the equilibrium position would have changed.
Correct.
Okay,
Because of
right
two
now,
mass.
if this is the natural length of the spring,
Yes.
okay, then this elongation was already like mg by
by
k. Okay, and now the new equilibrium is again,
2 mg by k.
yes, it is further. So this is the new equilibrium, and everything has to be measured from
Yes.
here. So the distance from here to here, that becomes the amplitude. Student invariably miss this.
Yes,
They consider
that is
this,
mg by k,
they consider
correct.
this, and they calculate this, and that is the fact that they miss. Okay, so now if any student who has realized this, it is very easy for them to calculate. We can write amplitude into like that is the equation for speed now, like v is equals to root of a square minus s square into omega.
Yeah.
Okay, so after collision we know the speed is this much.
We know by 2.
Okay, amplitude is what we are trying to figure out.
Yes.
Displacement from mean position. Now the student put 0 here. They think that this is the equilibrium position.
No, it is not.
It is not.
Actually mg
This
by
is
k.
mg by k, and another pitfall, omega is changed.
Yeah, it is not m by k.
Okay, it is-
k by m. Sorry.
Yeah, so omega would be here, it would be
K by 2m.
k by 2m.
Correct.
So from here we get the value of
Squares.
amplitude,
Perfect.
and then what do we do? If we can go to the next one.
Okay.
So if I draw a circle now, because I have the amplitude, I can draw a circle. If we are taking projections on the x-axis,
Or we can take y-axis also now.
okay, yeah, we can now take y-axis. I think
Because
so.
it will be easier to
Yeah.
visualize.
So from mean position, the particle was upward displaced. This displacement was mg by k.
Correct.
Okay, this was displacement was mg by k.
Correct.
And after the collision, it was moving in the positive direction.
Positive
So
direction.
here we will take it.
Yes.
So this angle becomes the initial phase. This is A, we already know. So sine phi would be equal to mg
by k
by k by
a.
A.
And
Okay, so from here we can get the value of phi. Now the question was that when is the spring maximum compressed? So when this will be at the highest position, at that time the spring would be maximum
Yes.
compressed. So pi by 2 minus phi by omega, new omega prime, or I'll just write the what we should be writing. It would be root of
k by 2.
k by 2m.
Yes.
So what are the places where the student commit mistake? So if I go back, one is missing out on this.
This part, 100%.
Okay, the second mistake is missing out on this.
This, correct.
Okay, so this
New
is the
omega.
so these are the common places where the student commits the mistake. And
Correct.
if you would have tried, guys, independently without looking at the solution, most likely,
Most of you.
if you would have reached till this stage, this is where you would have committed a mistake.
Yes.
Most of the student will probably not be able to reach till this stage also.
Correct. This is very true. I hope you understood this part of the problem, right? Like, the angle is again, what do you say? This was the time, if I'm not wrong.
Yeah,
this was
this was
the time. And time is again angle by angular speed. Angle covered is from here to here, divided by angular speed. That is the, k by 2m root. And why this angle? Because when you reach here, you have compressed the spring by the maximum amount. Okay. And I hope you understood why this sine of pi is mg by k, because this is mg by k, so this is mg by k, this is hypotenuse. So opposite side by hypotenuse, right? I hope this is all right. Very good. Wow, sir, this is super duper cool. And phasor diagram is so much fun. And I think at least over here, the omegas were same. I think it would become very interesting when omegas are not same.
Yeah.
Like, the phase angle will not be constant, and that phenomena of beats will come in.
Yeah.
So I hope you realize that the phenomena of beats is just this, with a slightly more complex scenario of omegas being different. And then you can make it even more fun with 3 phasor diagrams with 3 different omegas, where, it's also there in JEE. You can look it up. Okay. So this is very, very interesting when you look at it from the phasor perspective properly.
And this method also helps you in solving questions related to alternating currents.
Yes.
Like if again there are time-based questions in alternating current, that
Yeah.
at what time so and so will happen,
Correct.
then phasor diagram becomes very useful.
Yeah, that's what, guys, see, AC circuits never ever had those formulas just for the sake of it. If a student understand what the phasor diagram is, just by the knowledge of trigonometry and vectors, you can get the answer very easily without breaking your head and remembering those complicated formulas in root and all of that. Okay. Yeah. So, my dear students, this was just the trailer, if I'm not wrong, sir.
Yes, sir, definitely.
And the entire picture is obviously there in Ekalavya. Sir is teaching in Ekalavya plus teaching in the NSCP batch, the Physics Olympiad batch for 2025, and the JEE Advanced batch, which has just started. The phase 1 has started. And in the phase 1, it is actually like watching a picture only, sir, because they don't have to do anything.
No, they just have to watch what the teachers are doing. Hopefully, they will retain some of that, and
Yeah.
that is good enough for us.
And the class timings are in the night,
Yes.
so that it does not coincide with your actual any coaching, online, offline, doesn't matter.
Yeah. So, students, I'll just say this, that suppose you don't know about Eclair.
Okay.
Don't assume that it is not worthy of your time and move on. Like, if you don't know about Eclair, please inquire about it. Okay, there are sessions on this channel that you can see. There are sessions that you will find on Google. There are testimonials from previous Eclair students that you will find. Do spend 15-20 minutes doing your own research on Eclair and then make an informed decision whether you want to be a part of this or not, because you may just discover that ignoring anything about Eclair today could turn out to be a very costly blunder for you as far as your
100%.
IIT JEE dream is concerned. You know, your competition is gaining an edge over you. You should not miss out. Okay, you have to be in the race, and for that it is important that you know at least that what Eclair is all about.
Very true. So, my dear students, the phase 1 is going on. Phase 2 will start later on. By the time your usually syllabus is over in any kind of coaching. So, now is actually the right time to get into the flow. Don't think, many kids had asked me last time, sir, can we join in phase 2? I said, yes, you can join in phase 2, you can join in phase 3 also. You can join in phase 4 also. But then your probabilities are going to reduce, guys.
It's like you're starting a race late. You're letting others to move ahead, and then you're saying that, okay, I'll enter into the race a bit later on. And also, guys, understand this. Phase 1, it's not about academics. I will deliver academically great content to you guys, but my perspective is different. I want to instill the IITians attitude in you. Like
Right.
during our interaction during the session, my focus would be to let you know that how the IITians behave and how you should be behaving. Okay, how you have to transform into an adult from an adolescent kid. Okay, so that is very important for you to understand that when you walk out into the world, okay, at that time how mature you can behave. That is all about IIT. You have to
Think like, you start thinking like an IITian
Yeah.
even before you enter IIT. That is very important, I think.
and that's how you reach IIT. When you start acting like one.
Correct. So, if you are interested in even in this video and even in the description box of this particular podcast, you can definitely watch it and smash the like button, join, subscribe. You can see Ekalavya JEE 2026 link is there. All the details, it's in pure English, by the way. Okay, same teachers, guys. In fact, all the brilliant Olympiad and Ekalavya teachers are only there. Sir is also there. AP sir's guidance is there. I mean, all the teachers are the same teachers who produced this year's All India rank 15 and also the gold medalist, in the Olympiad examinations, be it Physics Olympiad or even the Mathematics Olympiad and even before the Astronomy Olympiads. And right now, see, usual price is 20,000 rupees, but obviously we are giving it because you are early birds. Phase 1 is considered like an early bird. So 12,000 rupees. This is a pure English batch, entire syllabus for JEE Advanced, and the only difference between this version and this version is the rank accelerator book, which will be delivered to your home. Otherwise, you are still getting the soft copy. So if you want to save 1,000 rupees, go for this. But if you want to save your eyes, then go for this, because how much will you watch and read everything online. So save your eyes. The batch has just started. This rank accelerator book has amazing pure JEE Advanced questions, sir.
Yes, questions like minimal collection, like a minimal number of questions which are essential for complete exposure of concept and variety of question in every chapter. So
Okay.
every subject has about 1,000 questions,
Nice.
total 3,000 questions, and once the student does all these questions, the student is totally prepped up for JEE Advanced.
It has both level 1, level 2, if I'm not wrong, and chapter wise segregation with solutions, everything is
yeah.
there. Okay, perfect. So guys, do not forget to check this out. The link is there in the description. And yes, like the video right away, right now. So thank you so much, sir. It was amazing to have you here. But guys, if you want more such sessions, you need to comment below. Okay, only when you comment and like, then only I will call sir, or else I'm not going to call sir, and sir will also not come. He will also feel bad that, oh, students are not calling me, why will I come? So please like and comment. Okay, thank you so much, guys. Bye bye. Take care.
Bye, students.